Basic Statistics by Hand is an episode of the Degrees of Freedom project. Videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description. This video gives an example of calculating and reporting the mean and confidence interval from a set of measurements by hand with a calculator. We begin with our set of measurements. They are 5, 7, 4, 6, 4, 6, 5, 7, 5, and 6. Adding in pairs, they are 12 plus 10 plus 10 plus 12 plus 11. That is equal to 55. The number of measurements, or the count, is 10, so the mean is 55 divided by the count, 10, or 5.5. We next need to calculate our residuals, or the distance from our measurements to the mean. This distance is given by 5.5 minus each individual measurement, or 0.5, negative 1.5, 1.5, negative 0.5, 1.5, negative 0.5, 0.5, negative 1.5, 0.5, and negative 0.5. The squares of our residuals are either 0.25, or since 15 squared is 225, then 1.5 squared is 2.25. So the values of our residuals squared will be 0.25, 2.25, 2.25, 0.25, and so on. The sum of our residuals squared is 4 times 2.25, or 9, plus 6 times 0.25, or 1.5. The total is 10.5. The variance is that sum divided by n minus 1, where n is our number of measurements. So our variance is given by 10.5, or 21 halves, divided by 9, our number of measurements minus 1. That gives us 7/6, or 1.167. Our standard deviation is the square root of that variance. But I can't do that in my head, so we can calculate it to get 1.080. The standard error is that value divided by the square root of 10, or number of measurements, or 0.3416. Looking at the two-sided t-table at p equals 0.05 and degrees of freedom at 10 minus 1, or 9, I get a value for t of 2.262, resulting in a lambda of 2.262 times our standard error of 0.3416. Our lambda is therefore 0.773. The value of my measurement is then reported as 5.500 plus or minus 0.773 with 95% confidence. Thanks for watching. This video was brought to you by the DOFPro team.